right, so here we go again for our review. We're going to be looking at some of the evens. If there's some of the evens that we don't go through on here, it's because either we've done something very similar with an odd, of which there's a video up, or also you can look at the absolutely worked out key online on my website, huskiesmath.edublogs.org as well. Now, number 2 we are actually going to do, and here's why. We chatted a little bit in the odds video about looking at our 2 fractions on the left for our people that are working alone on a job, and then on the right where they're working together. Now, this first one, we had 2 people that were working alone. We figured out how long would it take if they worked together. Number 2 is going to turn out a little bit differently. Working together, Joe and Arjun can pick 40 bushels of apples in 5.32 hours. Notice, working together. The together fraction is always on the right. So that's where my 5.32 would go. Had he done it alone, it would have taken Arjun 13 hours. How long would it take Joe to do it alone? Now, is that going to change anything as far as me figuring out a common denominator or working this out? No. No, it is not. So, when I get to that part, I'm going to go ahead. Let me try and tune this down a little bit. I'm going to multiply my 5.32 times 13. So I end up with a common denominator of 69.16J. And similar to what we've done on the other fractions before, we're going to go old to new. Now, really with these, when I look, I go, okay, I see I'm going to need the J. I have no idea 13 times what is this. Well, I'll go along with you. I don't have a clue either. So, we're going to just divide the 13 in, and that's what's going to go with my J. Here, I've already got the J. I need the 69.16. And here, we talked about this a little bit yesterday. I bet you know what 5.32 times what gets you to 69.16. Think about it for a second. Maybe look a couple to the left at 2 fractions. 13 times 5.32. Now, could I still, plug it in my calculator? Yeah, but I don't know. There's just something about being able to bust out a number like that kind of makes you feel smart. So, an equation, again, that's when we can get rid of this. 5.32J plus 69.16 equals 13J. You're like, what's different? We did the same stuff up there. What's different, if I slide this over a bit, is the first time my t terms are on the same side. I just put them together. 16 and 14 is 30. This time they're on opposite sides. So to get them together, I have to do an opposite. I can't just throw them together like I did over there. So 13 minus 5.32 would be 7.68J. And we divide 69.16 by our 7.68. And we get this funky looking decimal. Since we're rounding to the nearest hundredth, we go to 9.01. Okay. Now, number 4. Number 4, we're not going to go crazy with. We're like, why? Why am I not going to go crazy with number 4? Because number 4, check it out, is very similar to number 5. You have one parenthesis term, one constant term. I need both of them to be my LCD, and then I'm going to build fractions. Okay? So that one, if you're looking for a more in-depth answer, you need to look at the key online or look at the key in class. We're not going to go do the entire one again when we just did one like this. Anyway, you need the practice. Check that out and come back if you've got some questions. Now, we do run into a different one on 6. Okay, when we get to 6, I parentheses around here. We'll get that side. And I go to look for my LCD. I start thinking about my little LCD Post-it note, which mine has disappeared, as I can look around here. So I'll just run through it. Okay, number 1, do I have any coefficients? Nope. My numbers are stuck in parentheses. Do I have any single variables? Nope. They're both stuck in parentheses with plus and minus. So my LCD is just going to be my two sets of parentheses. And again, we could do the side work thing if we needed to, but let's really look at this for a minute. If I'm comparing this to this, I've got the x plus 4 already. I do not have the 5x minus 6. Got the 5x minus 6. I don't have the 2x plus 4. Now, this part now, and again, this is not an equation. Do not cancel out the denominators. Don't reduce stuff. When we have an expression that we're simplifying, your job is to simplify the numerator first. So until you've done your distributing, be careful. This is a minus. We've talked about moving that up to there and distributing. (10x minus 2x is 8x. Negative 12 minus 8 is negative 20. And before you circle it, before you say it's done, is there anything in your numerator that can factor or simplify? Okay? If it can, and I don't mean these x's, don't you even do... They're both divisible by 4. Now, does that mean every time I do this that something's going to cancel because of it? Not necessarily. And in this case, it doesn't. But about the time you don't, it will. So you've got to watch for that. Number 8, I'm going to help you build the LCD, but then I'm going to leave you on your own with it because it's really similar to number 7. So I've got my parentheses. Before you start building your LCD, is anything factorable? Mm-hmm. 2 out of there. Now I can start building. So again, I'm going to look. Do I see any coefficients? I do. That's included. Do I see any single variables that are in bottom with plus or minus? Nope. And then my sets of parentheses, my quantities. No canceling. And then we go into builder mode. I got the 2. I got the n plus 3. I need the n plus 5. Here, I got the n plus 5. I need the 2. And I need the n plus 3. And again, I would even go so far, this will kind of be my last hint with number 8 here. I would take my 6 times 2 and turn that into the 12 before I started to distribute. But once you distribute and, combine your like terms, see if there's anything that's factorable left. If there is, do it. If not, that's going to be your answer. So something to keep an eye on. Now, 10 and 12. And again, answers in the answer key. If it's division, we'll say this again, we're going to flip the second fraction. Now, it's important, before you start factoring and stuff, if there's a division, that you do your flipping right away. Well, why is that? Because now, for those of you that hate factoring, check it out. These sets of parentheses are identical already. Don't even bother. If they're the same, shoot, be done. Okay, that's a B, not a 6. 3B, not 36. So that's kind of cool. But here's where we can't take that to an extreme. Number 12. And people will do this. And I'm even talking about it right now, and people will still do it when we get to the summative. For some reason, people will see the numbers 27 and 45 and assume these are the same and zap them. But they're not. This has n squared and this doesn't. Okay, so what does that mean? It means we need to look and see, can we factor them? Can we take something out? So whether I'm using my multiplication chart, using a calculator, doesn't matter. These are each divisible by 3. So I take a 3 out. Now, let's say I take a 3 out and then I notice something. I'm like, hey, I can still take 3 out of both of those. Oh, I didn't take the biggest number out, did I? Dang. 9 would have gone into each. That's okay. 3n squared minus 5. Okay, so notice it's not a... Oh, Harty. This is one of those times when you're doing videos. This is kind of embarrassing. It's kind of important that you copy the problem correctly, isn't it? Yes, yes it is. Okay, so they had an n in common as well that we need to pull out. 9 times 3 is 27, n times n is n squared. 9 times negative 5 is negative 45n. Okay, it took us how many times there? 3, I think, but we got it right. And now it helped us learn a lesson that 9 is the number that's going to come out up here. So, what does that allow me to see? You're like, Harty, with the mess that you just made on this paper, not much. Well, let's try and fix that. So 9n over 9n, 3n minus 5 times 9, 3n minus 5. Okay, there are all sorts of things that can get me into trouble here. 3n minus 5's cancel. Good. 9n's can cancel. Good. It's 1 to 1. I can't cancel this 9 with this one and then zap this 2. It doesn't work that way. So at this point, I look and I'm like, what do I got left? I got 9 over 1, or 9. Okay, I'm good. And so I've got to watch for those things. Okay? It can be those little things. Now, sometimes you may get a difference of squares, but that's what you've got the help sheets for. Okay, simplify and state the excluded values. Oh, one of our favorites from the last quiz. Okay, this here, that would be a difference of squares. Because I square p to get p squared and 1 to get 1. Does that mean now that I just write p minus 1 and I'm done? No, like 50% of you that did that on the last quiz. It's on the help sheet. Use the sheet. A difference of squares is 2 sets of parentheses. Your first plus your second and your first minus your second. Not just the one with the sign in the middle. Those cancel. But if you cancel everything in the numerator, there's still going to be a 1 there. So, can I cancel these 1s now? You better not be saying yes. If you do, you need to, lash them with a wet noodle. All right. As I keep rolling here, again, these next 3, wait a minute. I'm going to go down to 20 in a minute. These next 3 are very similar to the ones that are next to them. Here's the one thing I'm going to keep reminding you of, though. Do not cancel these. They're all bonded. Factor that. Then see if there's an n plus 9 that shows up. When you get down to here, don't you dare cancel out those k squareds. Because you know what I'm going to do? I'm probably going to write on your test somewhere, yep, not listening whatsoever. Because that's not effort. That's the lazy way out. They're both diamonds. We've been doing diamonds forever. Factor them. If you need to see an answer, again, check up front, check on the key online. Now, number 20 I am going to do, because 20 is a special case. So we're going to factor both of these. And once we do, I see all pluses. Oh, that's always nice. Multiplies to 27, adds to 12. Here, I get the same set of parentheses for both, because 9 times 9 is 81, and 9 plus 9 is 18. Does that mean I can zap all 3 of the x plus 9s? No. Does that mean I can zap these 2? No. 1 on top, 1 on the bottom. What's left is the answer. So again, you're noticing a pattern here. With your regular problems, you've got to find, okay, factor, 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 cancel, cancel, cancel. It's different than when we have the equations. And so finally we get back here into the back. And again, the setups for all of these evens are the same. Find the concentration of a new mixture. What's the concentration? They're the same. Use this one to help you set up this one. But you need to be able to set up this without a help, because when we get to the test, you've got to be able to do it on your own. So let's see here. How many ounces of nuts need to be added? How many ounces of saline solution need to be added? Similar. Use them to help you. And then 26 does the same thing. You're like, dang, you didn't do much on this one. No, because you're the one that needs to practice. Okay? I'm helping you out with this. Use these 2 videos if need be. Okay? Do the comparisons. Check the keys. Do what you need to do. Let's make this a successful test. But you know what you need to do? Practice, 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 practice. Do your homework if you haven't. That's the best advice I can give you. Peace out. We'll see you tomorrow.